I want to make a wheel to go on this motor shaft, and I want to make it out of polyoxymethylene, which is basically a very tough engineering plastic. Cool stuff, and you can get offcuts of this on eBay for pretty cheap. The machine of choice for this would obviously be a lathe, but I don't have one. So what I could do is drill a hole, stick the thing on the motor shaft, and then turn it freehand using a woodworking chisel. I did exactly that making this pulley, while I had it mounted on a separate shaft and then had the motor turn it, but it's the same idea. It works alright, a little chattery maybe, but that might be because of how I treat my chisels. Okay, let's pause this for a second. The truth is, this method doesn't work alright. Because in order to turn the wheel on its own bearings, you have to create the recesses for the bearings first. And how would you do that? Probably using a Forstner bit. But how are you gonna make sure that those holes will line up perfectly? Well, you could drill a small hole through the piece and then use it to start the Forstner bit from both sides. But as a matter of fact, this small drill is not gonna go all the way through the piece in a perfectly straight line. So I suppose you could just simply mark each position on each side. Yes, but for both of these methods you would A, have to make sure that the blank is a perfect cylinder or cuboid, but remember you don't have a lathe or a mill, otherwise this entire trip wouldn't make a lot of sense, and B, you'd have to be extremely precise with your measuring. Not a big deal, it still works, kind of, but for the next set of wheels that I made I used a method that I'm gonna show you in a second. But today I wanna machine this wheel at the drill press. And the first step is to identify the center, and I'm gonna use my homemade center finder. Okay. If you are so sophisticated, you can grind yourself a custom set of drill bits for drilling soft materials like plastic or brass, but I'm not gonna do that. Okay, my camera quit before I was all the way through, but I think you can imagine how this went down. Now I need some way of mounting this entire thing to the drill chuck, and I think I'm gonna use the drill bit itself.
And now I'm gonna mount this on a piece of steel shaft. And there should be a tight friction fit.
This way. I made this jig so that I can mount my little POM router to the drill press table, and I'm now gonna use this setup kind of like a router lathe. Now that looks funny. Alright, here it is. I just need to clean it up a little bit. This method definitely has one downside. These shavings are electrostatically charged and they stick to everything, even my face. I'm just gonna mark where the keyway needs to go, and I think I'm gonna try to cut it using the jigsaw. Wow, I didn't expect that. Perfect. Isn't that just neat? Machined from a solid chunk of plastic. And I love those machine marks. And it seems to be a tight fit. Now I'm just gonna have to make some sort of a steel disc that's gonna allow me to bolt the wheel to the motor shaft. If your tool has too much runout for your machine, you just have to use a wobblier machine. I'm gonna mark its orientation just in case it comes loose or I'll have to remove it again. Oops, and it came loose. Okay, I reinstalled the motor and I'm now gonna install the wheel and then we're gonna check it for runout. Now I could touch it up with a chisel, but to be honest, I still need to show you how I cut the recesses for the bearings. And now with the router vertically and a ball bearing on this shaft, I should be able to set this up to cut the recess for the bearing. I ended up putting my girlfriend's hamster Willy bolt in there, and he seemed to really enjoy himself. At 20 RPMs he kind of started struggling a little bit, and then I cranked it all the way up to 5000. And well, yeah, he just couldn't keep up. Unfortunately I didn't film that because that would kind of contradict my vegan lifestyle, that you can now check out on Instagram.